Hello, mathematics teachers, professors, authors, and students. My name is Dave, and I would like to share with you an open source function, equation, points, and vectors plotting studio that I've been working on over the past week and change. I have just published the application for access, free of charge, at https://dedekind.app, where you can find a link to the source code, which has been published and is regularly updated on github.com. Today, I want to show off one of our most unique features yet. Our studio allows performance and interactive plots of implicit surfaces defined by equations with respect to x, y, and z. There are a few examples on the front page, but I'd like to show some of our features off, while giving a special look at another couple of plots just for those watching on YouTube. Here you can see a nice animated implicit surface going on in the bottom right. We draw implicit surfaces using a ray marching fragment shader. This allows extremely high levels of detail with minimal to no hit on application performance. In fact, many animations play at over 100 frames per second on my device. In the canvas, you can see that we have two 3D cameras viewing two different implicit surface plots. Wired directly into the cameras are transformer nodes, which take different plottable node kinds and allow domains, resolutions, and for pure maps, axes of input and output to be given to represent the object. Our equation nodes are currently set to surface and XYZ mode, erroneously labeled marching cubes at the moment. In the variables section, input variable names may be defined so that x, y, and z can be used in integral expressions and such. In the relations section, we can set our left-hand and right-hand expressions. Right now, we have some a's and b's sprinkled into our expressions, so we can morph our plots with sliders and animators. Between our animator node and our bottom equation is an expression node, which allows wired inputs to be evaluated and passed into other nodes. Right now, we have our animator set for 0 to 2 pi with a period of 4 seconds and our expression set to sine of t for a smooth back and forth animation. I will now fiddle with the sliders for you watching at home, but I must tell you that every single camera viewport with all sliders, animators, and plots attached can be opened in a browser tab with a URL which can be copied from the camera's properties panel, where you can change what sliders and animators are visible and modifiable to viewers, as well as the camera's background color. Anyone who is interested in learning to use this software as a teaching aid or to embed into articles or books is welcome to join my community chat at https://mm.davig01.net. Enter the Dedekind team to talk about Dedekind. Thank you all so much for watching.